So what exactly is it? Uh, which now that I've talked a lot about it, might be good to good to get into. But it's owned by a company called MathWorks. They develop it, and they have a whole suite of MathWorks software. You might have heard of MATLAB. Simulink kind of lives in MATLAB, and uh, it's all sorts of software for code programming, simulations, all of that. Especially used in kind of mechanical engineering, thermal engineering, that sort of thing. um, and Simulink is very useful because it's kind of block-based programming. You'll see that later, but it's great for simulating, large complex systems that are a little bit harder to do by just writing code. Uh, Now, what is the benefit of actually using it best? There is, like I said, it might make your software development easier, but more than anything, there's a prize for Simulink. There's also a software section in the notebook, as you know, which you can use your Simulink development, something to write about there. And finally, in the new engineering notebook score sheet, uh, there is, a specific part of it for showing that you did make a robot model on Simulink. So, you know, there's no reason not to do it. So, what exactly, I've said a lot of terms. This kind of just spells it out a little bit more precisely. So, what exactly is all the software? So, we have basically MathWorks owns Simulink. Simulink is part of the MATLAB system. You download all of it at once, and you basically get a license. You can either download it on your PC or a Mac. It's both are supported. The only issue is on a Mac, you can't upload code to the robot. So it's a 1 year license. It's free for everybody. You just have to go online and request it. I have a link to that in the slides here, which I'll let you guys peruse when we send it. But exactly what it is, like I said, is block based. So you drag and drop different function blocks and you connect them to build a model. So, here's an example like a thermal model of a house. So all of the places that heat gets transferred uh, and measured are all different sorts of blocks that are set up in the model. And you're able to see how, information, in this case, heat flows through a system and all of the things that interact with it. And you can see, what the temperature is at all nodes of the system. That's just one example, right? I'm sure based on that, you can think about all sorts of ways you can use it for your robot. Like I said, it runs on top of the MATLAB language. It works for Windows and Mac. There's all sorts of tools for plotting, debugging, doing, engineering analysis. It does a lot of complex math for you. So it is really, really powerful. There's also a browser-based version that isn't as powerful, but you can access that here. And like I said, it's free. You just follow this link, and you can request a license. Uh, I think your school has, your team advisor needs to do it, but then you should get it within like 72 hours. And I'll gloss over all of this because this is all the details for installing it. But if you do have any trouble getting it and getting your license, just reach out to us. Um, so with all of that, glossing over the installation because I want to give more time for questions in the live demo. Um, One of the key things that I just want to emphasize, Simulink is graphical. It's based on building blocks, right? So you have to grab blocks out of a library of blocks and connect them. You can expand the library of blocks by downloading add-ons. That's what the Simulink, VEX package is. It adds a bunch of, blocks with their own functionality to simulate the servos and the joysticks and so on and so forth. But key to it is the library. And in the Simulink window on the left, clicking on the library browser is where you get all your blocks from. So that is probably conceptually, if you take one thing out of it, Simulink, you need to just build it block by block, and all your blocks come from the library. You can search it, but if you're missing blocks, then you might need to look into your installation and make sure that you downloaded all the robot brain packages and everything correctly. So I'm just going to talk through a programming example of how to build these blocks. In the past, I've done this with live coding, and sometimes that goes better than others. So I'll leave the demo to Charles, who'll show you kind of a more complex example, and just talk through the simple example with you guys on the side. So basically, what you do is you open, when you have it installed, you open a MATLAB application, and then you click on New and Simulink Model. And from there, right here, on the top left of MATLAB, click Simulink Model, and then start it that way. So just a little bit more terminology, which I know is kind of boring. Uh, the support packages in Simulink are all of those extra building blocks that I was talking about. So, you install that separately. The Simulink apps, there are companion apps you can install as well. These give you more of like a user interface. There's something called a VEX companion app, which I kind of glossed over in the installation slides, but it is a very valuable tool that allows you to kind of more graphically design a lot of these Simulink systems. It is not compatible with the 2025 version of Simulink. So make sure when you request a license and download, make sure you download the 2024 version. That'll give you access to all the features that you need, but make sure that you're backward compatible with this companion app. A Simulink model is the overall, connection of all the building blocks. For the major use case for BEST is building the robot program, right? The blocks are the individual functions. You can build the blocks from, the library that I showed you. And finally, a lot of people have asked, you build this as blocks, but can you do this as code as well? The answer is yes, but a lot of times simulating these complex systems are a lot easier to do visually than with code. But you could automatically generate and export a Simulink model as C code. And then when you run a Simulink model, you just simulate it. Let's put all of this together. These are just kind of what these blocks look like. Basically, to add a block, like I said, you add it from the library browser. You drag and drop them from one. If you click on one side of the block, an arrow will pop up, and you can drag the arrow to link it to another block. Some blocks can be configured, so you just double click on the block. You can access the different configurations. Like top right, there's a block for a math function that has all sorts of different functions in there. If you double click it, you can specify what that is. So just basic example, implementing an equation. Some equations make a lot more sense to implement in Simulink than others, right? This is not one of them because everybody knows how to solve the quadratic equation, but it shows, kind of conceptually how to build these blocks. So basically what you want to do is for a constant times the square root of the quantity x squared plus y squared, you want to get the answer to that, right? So that's your output. X and Y are the inputs, and you add a constant to it. So there's many ways to do it because there's several different options of blocks you can use. One of the simplest ways to do it, so every time you click on the top left for the library browser, right up here, which launches this window that you see on the right, and then from there you can search and add your blocks. So you add two constant blocks. They're literally called constants. You can label them. So one is X, one is Y, and specify their values. In this case, we're just going to call them 1. And then you drag those over into a math function block, right? And then in the math function block, like I showed here, you can select that as a square. So now you're squaring both of these, right? So that takes care of the inside of the parentheses. And then you have to add them together. So you add an addition block, you link both of those outputs to that block, and then you link that sum to the square root block. Right? Now you're taking the square root of that quantity, and now you just have to multiply it by a constant. So we add another constant block, and we multiply it, and that's that. Finally, the output is something called a scope block. There's several different output blocks. Each of them have their own sort of thing. You can even simulate the inputs. You can even say, like, to actually drive home the point of why this might be useful. Let's say that X and Y are constantly changing, right? So you can simulate X and Y as some function, right? You can say X is, a sine wave. How does that affect the final equation? and you can see a graph of what the final equation looks like as X and Y vary. You can change them to random blocks, that sort of thing. So it is pretty powerful for that sort of thing. Sometimes, the products and outputs are linked back, to other functions earlier in the equation. That's when these things get really helpful. Um, so there's a lot of different resources for, understanding this. I gave, the highest level version of this, but I have it linked in here, so feel free to have a look. Um, Finally, I just want to give you one big caveat before I turn it over to Charles for the demo, which is um, in the new V5 brain, uh, do not use the DC motor blocks because it doesn't work. You'll have to use a smart motor block. So just keep that in mind. Um, and with that, I will turn it over to Charles to give you an example of what this actually looks like on a robot.
Thank you,
Are
George.
you able?
Try to
Yeah,
get it to share real quick.
let me know if you want me to toss the screen back to you, presenter mode. Okay, nice.
So it looks like basically I just have the MATLAB opened. I'm using MATLAB 2023, but it works on any version of 2024 MATLAB or older. And this is what it looks like when you open up MATLAB for the first time. I guess these files wouldn't show up over here. But if I download the example file from the link that I shared in the chat, and it's also linked within the PowerPoint that we're going to share, I could just go to open and then open this .slx file. It comes up as a Simulink model. And this is just an example default code. It's not exactly the same as the VEX code default code that's released for 2025 for best robotics. So we just put experimental as the name, and it's got enough pre-programmed to be able to run th 4 motors and a servo. So basically, you could get a basic robot started, and then the scrolling and moving around can be kind of odd on this. So a shortcut to learn along the way is press spacebar. If you click spacebar, it auto zooms or zoom fits and makes everything in that Simulink model show up. And then just to kind of go back over what he just showed, what George just showed in the slideshow, if I go up to the simulation tab,
Hey, Charles, real quick, I think you're showing the MATLAB window, but not the
oh,
Simulink.
evidently they're different windows. So I'll try to click and share one more time. Good catch. Did it switch over now? I
Yep,
thought I was
all good
sharing
there.
the entire screen. Evidently, I was just sharing the window. So whenever I first opened it up, it was zoomed really far in, and you can click and hold the scroll button to move things around to pan. But if you hit the space bar, it will kind of zoom fit and bring everything into the window that's on this. And you can see it's got 4 motors. If you were going to try to push this code to your robot and then just run it, the motor port 9 and motor port 2, the little numbers down here in the bottom of these blocks would tell you which smart ports you're going to plug motors into. And then you'll notice that we're coding using smart blocks. It's called the smart block write block instead of a motor controller 55. The motor controller 55 block doesn't exist. It's kind of a new component to BEST or to VEX V5. And then the servo does look the same as it has in the past. If I hit spacebar, it does zoom fit. And then just to kind of go back over the library browser and things like that, that George had shown, if I hit the simulation tab up in the top left and then click library browser, I have this coder support package for VEX V5 open, and then things are organized under, I guess, different folders here. There's a smart motor right, and the servo motor. These blocks could just be clicked and dragged out into this to be able to connect this kind of flowchart diagram that builds out your Simulink model. And that's where these things are coming from. There's also this little pop-out library browser that has this square with a bunch of colors in it. And then it brings up some larger objects to be able to see. So you can see like the gamepad, either using the digital buttons up at the top or the analog joystick axis. You can click and drag these out and then build your model that way. But I'm just going to start with this example model so we can kind of cheat and get a head start. And then I'm just going to show the basics of pushing to the hardware and running this, and then kind of talk through some of the programming we have here. In general, when you're setting up a program using Simulink for a best robotics robot, you would want to kind of organize where you have your inputs off to the left side. Then you would process those with some processing blocks and then output them to motors. So the inputs could either be something like the joystick controller, or it could be a sensor on the robot that's giving some kind of input. Then you would do something to process the input that you get values into something that the output blocks, usually motors and servos, could accept. So that's kind of how this is basically set up. And you can see down here with the servo, I'm going to be using the input as an A button on the controller, processing that. Anytime you double click a block, it'll also bring up information about this. This block basically says that whenever I press the A button, it's going to output a value of 1 or input a value of 1 into this system. And then if I double click the servo, it says that it's expecting a range from -128 to +127. So you can learn information about these different blocks by double clicking them and then looking at their parameter values. And with this basic code here, I'm just taking a value of 1 or 0. Either I'm clicking the A or not clicking the A. And then it's going to get fed into this gain block, which is a multiplying block. It's going to multiply either 0 or 1 by -128, and then feed that to the servo, which is half the range of the servo. So whenever I download this to the hardware and run it, I'm expecting to see half the range that I could program this servo to run. Because I'm going to be initially starting with 0 fed into it. But then when I click the A button, it's going to put an output a value of 1, which is going to get multiplied by a -128 and then sent to the servo block. And that's going to spin it, I guess, counterclockwise or clockwise as far as it can go in that direction from 0, which is half the range. And then I think I'll have to stop sharing and use my camera to kind of go back and forth. But all I'm going to do is up here in the hardware section up in the top is I'm going to click build, start, and deploy. And that's going to compile the code. And then down here in the bottom of the screen, you should see a little progress bar that pops up that says that it's compiling the code and it's going to download it to the code. And then I'm going to try to play a game of jumping back and forth between camera and the hardware on my desktop. So I have a robot brain that's plugged in with a micro USB-C cable. And then my code's still compiling, so it hasn't sent. This little icon that's here is from a code I pushed earlier when I was testing to make sure this works. But it automatically started running the code. So as soon as it finished compiling and downloading it to the robot brain, it started running the code, and this is what it looks like while it's running. So it's been running for 12 seconds, has a little counter. And then on my table over here, I have a servo extension wire plugged in with a header pin. And if I press the A button on my remote, I can see that it's spinning. It's clockwise if you're looking at it from the front, about 45 degrees or so. General rule of thumb is that whenever you're controlling a servo like this in Best Robotics with the robot brain, that you could get up to 100 degrees of rotation, give or take a little bit. So this is half of the rotation, that's about 50 degrees. And then just on the hardware side, to kind of go over that, I have this servo extension wire that is plugged into port A over on the side. These 3 wire ports go from A to H. Notice that's a male pin connector. You need to have a wire that has male pins to plug into that port. And then on the other end of my extension wire there, I have header pins because the end of my extension cable is a female connector. And then my servo that I'm plugging in is also a female connector. So there would be no connectivity there if there's no way to plug those in. So we have these header pins, and the 2025 season, it was recommended that these get super glued to the servo so that this just becomes a male connector instead. That way you don't have to worry about losing that header pin. But when you're lining them up and plugging them into a servo extension cable, make sure you line the white wire up with the white wire. and red wire up with the red wire. Otherwise, the servo just won't move. So that's talking through the basic hardware setup of moving the servo. And then again, I'm going to see that when I press A, that's the rotation I get. And then I could change those input values or my processing values to be able to control that to be more range. This is half the range that you could get. I'm feeding negative 128 to it right now. And then I'm going to jump back to what it looks like on the software side. And then additionally within this, I could run some simulations. There's a monitor and tune button up here to where I can push the robot code to my actual hardware and then run it. And then I can display some of these simulation values using that scope block. The display block here will spit out some numeric values to tell me what's happening in this code. And that can be useful whenever you're troubleshooting or just trying to understand what it is that you've set up in your Simulink model. So I'm going to try that and then run that same program on my hardware while viewing what values spit out to this. We can kind of talk through some of the code that we have set up here. This usually takes a minute or so. Don't know if it's showing up in the bottom of my screen, but there's usually some progress bars that pop up down there. And then you can see at the top, it's kind of gray right now. It's busy compiling this code and then sending it to the robot. Also, before I clicked monitor and tune up here, I had my stop time set to 180 seconds. So this is only going to run for 180 seconds and then it's going to kill the program. So now it looks like it's going. If I click the A button on my controller, you can see that the little display block here is spitting out a negative 128. So you can also display into like graphical interfaces. So you could simulate your inputs and have buttons that you can click with a mouse, or you can even use an Xbox controller and hook that up to be able to feed in as these inputs for simulations. And then this processing block is basically just multiplying. Right now, I'm not pressing A, so this is taking as value of 0, multiplying by negative 128, and then sending a value of 0 to the servo. And then if I click and hold the A button, this is now spitting out a value of 1. It's being multiplied by that, and you can see its output is displayed there, negative 128, which is half of the rotation. And then we can try scrolling up to the top of this and look at some motors. Because the motor controller 55 block doesn't exist, that component that we're using in Best Robotics is only provided for competition within Best Robotics, so it's not really publicly available. And this software hasn't been updated for that component. However, we can kind of trick it and use this block, the smart motor right block for V5 systems. And the parameters that it states are kind of wrong because we're using it incorrectly. We're not actually using it with the correct device. But if I drive a wheel, so let's say this is the right joystick, so I press full forward on my right joystick, then you can see it's outputting a value of 300, and that's visibly, I can see that there's a full rotation of the motor. If I press full down on that joystick, so taking the right joystick and pressing full down, you can see it gives me negative 300. And then visibly I can see, so with some trial and error, basically configuring this smart block to be a 6-to-1 gear ratio, and then giving it a gain block of 300 divided by 127. With some trial and error, kind of seeing that the range that you get, whether you're just lightly pushing to do a slow speed or full up to go full speed, will give me the same output that I would expect if I use something else to program it, like using the V5 VEX code software to program it. They appear to be the exact same speed. And then if I increase this gain block any higher, it doesn't seem to give any more output. So that's just to give you a starting point with this example code of how to get a full range motion out of the servo and then half range motion out of the or a half range out of the servo, but full range motion out of a motor. And then I put notes down here as I was experimenting with this, and other volunteers within the BEST community have looked at this and kind of given me feedback. And it looks like this is a good starting point to just be able to get motion out of your motors using uh, this software. Trying to zoom out, it's loading still. I guess also I didn't know that it was displaying the before it went into the game block. So if I press full up on the joystick one axis, you can see that right now I'm pressing full up, it's putting out a value of 127. So this analog um, input basically from the controller gives a value of negative 128 at full down, and full up gives me 127. So the range of this block says it'll give me negative 128 to positive 127. And then empirically, when I actually try it and press full up, it's giving me 127, and down is negative 128. This is showing me the range that I get from this block. And then I need to take that value and do something with it to feed it to this motor port. And then just by trial and error, I found that this gain ratio will help me get full range. And then just for reference, I took a screenshot and included that over here. So this looks like it's a menu, but you can't actually click on it. It's just a screenshot of how that motor block is set up to be able to get full range. And then a PDF of this exported, just the whole overview of the example code, along with the SLX file, the Simulink model that I have opened here, is shared in the chat already. And then also we'll follow up with an email to share any changes or updates we find along the way. And then do you have anything to add to that, George? And then
No,
if anyone
that's
has any
great.
specific questions, we can come back to this and share the screen again. Once we get through our PowerPoint and get done presenting our information, we can come back to this and answer questions.
Perfect. All right. So I know Charles touched on this, but all of these can be compiled and downloaded. Um, and there are a lot more advanced features, that Charles had mentioned. You can create subsystems. So you can, if there's a group of blocks of Simulink code, you can encapsulate them as a subsystem and then make a giant block out of that. There's also, you can create sequential logic decision processes in the flow charts that, you can interact with. And there's a new external mode, which I encourage you to play around with. There's also some, one of the cool things is, like I mentioned, you can vary inputs and then see the outputs in real time. One of the most useful places to apply that is on your robot is measuring torque versus, your arm angle and, all of that, right? Because as you know, based on how far away your arm is, the distance, that sort of thing, it will affect torque. But that gets complicated to do by math by hand, right? It's a lot of trigonometry, that sort of thing. And Simulink, you can have that immediately plotted as you move the motor around. So very, very valuable stuff for doing, full on engineering design of your robot. As I mentioned, there's a VEX support, companion app. This again only works in if you install the 2024 version of MATLAB and Simulink, not the 2025. But there are a lot of demos built into that, and it is a very valuable resource. There is also a virtual game field that gets published every year by MathWorks and Best Robotics, where you can have a simulated version of your robot play on it. Very, very valuable. Again, I don't need to, I stress that to you guys. Uh, Finally, just in case none of this makes sense, or you have add-ons that aren't working or anything like that, you could. uninstall an add-on by going to add-ons, manage, and uninstall. So uh, finally, what I will talk about is on top of all of the engineering reasons why it makes sense to use Simulink, there is a design award. It's given to one team per region for the best robot program that was done using Simulink. Um, the team workflow and the repository we'll share with you has all the information with this recording, as well as details on how to submit. The cash prize value will be announced prior to the championship, and we have some examples of what the winning submissions look like from last year. Finally, I won't talk through this, but there's a bunch of additional training resources we have linked here on the next two slides. So when we share the deck, please feel free to look through them. And if any other questions come up, you can email besteducation@bestig.org. There's also office hours available if you click this link up here. Um, and that's for specific information on, troubleshooting and setting up, Simulink for Best Robotics. If you have more general issues with, installing it or the app crashing and all of that, we link you to MathWorks technical support here. And there are also, student specific help resources available linked down here. Uh, Finally, one last thing is if the license here is specifically for use on Best Robotics, the free license. If you do want to use this in the classroom or anything like that, you can purchase a school license, and your school will have to do that. So that information is linked here. And with that, that's all we have to present. So we'll open up the floor for any questions you may have.